Good afternoon. So I think my microphone on my computer has been fixed. Let me know how you can hear this, whether it's better, worse, or the same. Anyway, today we're going to start our notes on Earth's atmosphere. The standard that we're working to understand through these notes is the atmosphere has different properties at different elevations and contains a mixture of gases that cycle through the lithosphere, biosphere, hydrosphere, and atmosphere. Thermal energy transfers between Earth's spheres form air currents. So while that seems like a pretty hefty standard to cover, this particular set of notes is going to focus on the 3 I can statements listed here. So by the end of these notes, you should feel like you have some information to be able to describe the force that allows Earth to have an atmosphere, compare atmospheric layers, including information on their properties, and list several gases in the atmosphere. So let's get started. Earth's atmosphere. Well, what is it? It is a thin layer of various gases that surround the planet. Here is a picture that shows a view of the atmosphere from space. Something you need to understand about gases in general is that gas has mass and it also has volume. And we've talked about that mass is the measure of the amount of matter or particles that are in an object, and volume is the amount of space that an object takes up. We will further discuss both mass and volume of gases when we discuss the density within the main layers of Earth's atmosphere. The reason why Earth is able to maintain an atmosphere is due to Earth's gravity. So that is the force that holds the gases around the planet. Okay? It is a pulling force. Gravity is always pulling, never pushing. So looking at this diagram, you can see that there are 4 main layers of the atmosphere. Down here is the Earth's surface. So you can see like some mountains. Okay, these are the Earth's surface. Now, along the side is both the distance above Earth, or the altitude, in kilometers as well as in miles. And so we not only see the 4 layers, but we also are seeing some differences in the layers. This yellow line represents the temperature change with height. So you can see that the zigzag motion shows us that in some layers the temperature increases with altitude, and in some layers the temperature decreases with altitude. So we'll be studying both of these topics throughout the notes. We're going to start with the thermosphere. So let's study about what the thermosphere is. The thermosphere goes to the brink of gravity's hold, meaning it is the upper part of our atmosphere, farthest from the Earth's surface. It starts at about 80 kilometers above Earth and then goes up to 10,000 kilometers above Earth's surface. There are very few molecules in the thermosphere. There's vast difference between them. Sometimes they can be kilometers away from each other. So because of this, it is not very dense at all. We have very few particles, which is a low mass, in a huge amount of space. And so therefore, the thermosphere has a very low density. Now, the thermosphere is divided into 2 sublayers. The sublayer that's actually closest to the Earth's surface is called the ionosphere. The ionosphere is an area of the atmosphere where the gas particles have actually become electronically charged. And I'm going to show you a picture right now of the Northern Lights. This is a picture taken from the International Space Station. I'm sorry, it's actually a video. You may watch it on your own time by linking to Blackboard to the PowerPoint presentation. It mainly just has music to the different colored lights as the International Space Station is flying over Earth's surface. So the other layer in the thermosphere that is further away from Earth is the exosphere. So it starts about 500 kilometers away from Earth's surface or above Earth's surface and goes out to where space starts. And particles here are so far apart, they're hundreds of kilometers apart, and they can escape pretty easily into space. So that's why there's no true boundary between where Earth's atmosphere ends and space starts. And it's because of this vast distance between particles and the escaping in and out of space. Mesosphere. It's also known as the middle layer. Now that doesn't really make sense because there's 4 layers, and so middle would be in between the second and third layer. But this is the third layer away from Earth's surface or above Earth's surface. And it is located 50 kilometers above the Earth's surface to 80 in height. And in this one, you'll notice that the temperature decreases with height. Okay, that's an important thing for you to understand. And something different about the mesosphere is that the mesosphere protects Earth from being hit by meteoroids. Meteoroids are rocks that have broken apart from larger rocks in space, things like comets, and they are moving in space. Once a meteoroid enters Earth's atmosphere, it's then called a meteor. A meteor will rub against the particles that are in Earth's atmosphere, because remember, out in space there are no gas particles, and so once it enters Earth's atmosphere, it now has this friction from rubbing against the gas particles, and so that builds up heat, and so much heat that it actually catches on fire. We often call this a shooting star. So a meteor that is flying through the mesosphere and has caught on fire and now is breaking up into smaller pieces is a shooting star. Stratosphere. Stratosphere is the second lowest layer when you're going from Earth's surface upward. Or second highest layer, I guess that would be. But it exists 12 kilometers above Earth's surface all the way to 50 kilometers above Earth's surface. And you'll see here that temperature increases. So if you're looking at this x-axis, the lowest temperature in the stratosphere is right around negative 42 degrees Celsius, and it rises to almost 0 degrees. It has this is another layer that protects us, this time not from meteoroids necessarily, but actually from ultraviolet B rays. And so the stratosphere has a layer of ozone, which we're going to talk about more specifically so that you can answer this question perhaps later on in a quiz. So what is ozone? Ozone is a molecule, and it is written O3. So O with a little 3 beside it. That 3 represents that there are 3 oxygen atoms that are bonded together. So again, it just protects us from some of the radiant energy coming from the sun. Now let's get to the troposphere. This is the area that the air that we breathe and that we live in, basically. It is closest to the Earth's surface. It can rise anywhere from the surface to about 8 to 12 kilometers above the surface. And what's interesting about this one is that there is a steady decrease in temperature as you go up. You may have noticed this when you go to Colorado and you're skiing, or you're somewhere in the Rocky Mountains and you go up in elevation, or in the Appalachian Mountains. Once you go up 1 kilometer in height, it changes by 6.5 degrees, so your temperature is going to drop. Now, that's not even talking about if you're in the sun versus now when you're in the shade. That's just due to an altitude change. It is the densest layer. Let's talk about why it's the densest layer. Remember that density is mass divided by volume. I think we did this on the board earlier this year, where we draw a heart and say we love density, and then we cross it out. That leaves the top of the heart as the M divided by the bottom of the heart as V. Density is the amount of matter in a certain amount of space. So like we said, the troposphere is the densest of all the 4 layers of Earth's atmosphere. And this is due to 2 reasons. One of them affects more of the mass and one affects more of the volume. Gravity is pulling down on the gases in the atmosphere. So a lot of the gases actually exist closer to Earth. And not only that, but we have a lot of cycling gases. I'm sure you've heard of the nitrogen cycle, the carbon cycle, and then we've got the water cycle, which when that water turns into water vapor, then that's a gas. So we've got lots of gases that go through cycles, and a lot of that happens within the troposphere layer. And so we have a ton of particles in the troposphere. As you go up, the particles in each layer gets less and less and less. So as far as mass goes, it has a lot of mass or matter. Now, why does it have, and it has very little space, so why does it have very little space? Well, think about it. The troposphere is on the bottom, closest to Earth's surface. We've got the stratosphere, the mesosphere, and the thermosphere above it. So therefore, there is lots of pressure pushing down on that first layer closest to Earth's surface. Therefore, the space that takes up is less. And so we have a great amount of matter packed into a small amount of space. When you divide that out, you get a very large density. The opposite is true for the thermosphere, which is the outer layer of Earth's atmosphere. Now we're going to stop here and pick up in class with the Smart Monkey talks.